All right, this video is looking over the example on page 189. It's example 3.15. And we're going to be looking at the two basic rules of probability again. So we have the multiplication rule and the addition rule. So here we go. Carlos plays soccer. He makes a goal 65% of the time he shoots. He's attempting to make 2 goals in a row the next game. So A, the event Carlos is successful on his first attempt, 0.65. And then B, the event Carlos is successful on the second attempt, 0.65. But things change a little bit. They give us more information. Carlos tends to shoot in streaks. So the probability he makes the second goal, given he made the first goal, is 90%. So what's the probability he makes both goals? So to do this, we first of all need to notice that attempt 1 and attempt 2 have an impact on each other. If they had no impact, if they were independent events, we would go ahead and multiply 0.65 by 0.65 and we'd end up with our answer. But here, once we make the first goal, the second probability changes. So to make probability of goal 1, or to calculate the probability of goal 1 and goal 2, which is the same, we can write it that way as well. And we know the probability of goal 2, given goal 1, is 90%. What we're going to do is calculate our probabilities. So here they're writing out the formula. P probability of, well, they kind of wrote it backwards here a little bit. It's probability of goal 2 given goal 1 multiplied by the probability of goal 1. So they did goal 2 first, multiplied by the chance for goal 1. So here's making our first goal. And then here, once we make that, the probability of making the second goal, and we multiply those together. So 58.5, 0.585 is our probability for making the first and second goal. Okay. Kind of wish they had written that as the 0.65 first, but hopefully you understand what's going on there. What's the probability that he makes either the first or the second goal? So the key word here is or. So first or second. So to do this, that means he could go make miss, or miss make, or make make. So to do that, we're going to calculate a make on the first, a make on the second. But if we add those up, 0.65 plus 0.65, that would be 1.3. You can't have a probability of over 100%. So we need to subtract. If we think about our Venn diagrams, we have those circles, we have 2 overlapping circles. We need to subtract all the ways he makes shot 1 and shot 2. So we're going to subtract shot 1 and shot 2 both going in. So 0.65, 0.65 added together. Then we subtract that intersection. We end up with 0.17 or 0.715. So 71.5% of the time he makes just goal 1 or goal 2. Or sorry, he makes goal 1 or goal 2, or both as well. This is counting both. Even though we subtracted both, we double counted it here by counting the A and the B. Because remember, when we looked at those Venn diagrams, it was overlapping in the middle. So we counted that twice. So our goal 1 and goal 2 independent. So independent means they don't have an impact on each other. And they told us up in the explanation that the probability that the second goal goes in increases if they make the first one. So they're obviously dependent. So they are not independent. And we can prove that by showing the probability of B and A, which we calculated up above to be 0.585. That's different from probability of B times probability of B times probability of A. So the chances of making it twice in a row are much higher than just the pure chances down here, because the chances go up after he makes his first goal. So those two numbers do not equal each other. So therefore, they are not independent events. Are they mutually exclusive events? That means if we make one, we can't do the other. And they are not, because there's a huge intersection. A lot of the time, this person does make both shots. So there we go. To be mutually exclusive, they must equal 0. All right. Thanks for listening.